from RMD Engineering College. We'll see about Mealy Model. Here, the Mealy machine is a finite state machine whose output depends on the present state as well as the present input. Whereas in Moore model, it was only the present state. So here the behavior of Mealy machine is given by the following equation. That is, the next state is a function of present state and input. So here they have given a state diagram. So state diagram, you can see A, B, C. Here from this state, when the input is 0, it goes to the same state. At that point, the output is 0. Here, as per the diagram, from the state A, it goes to the state B when the input is 1 and the corresponding output at that point is 0. So, likewise, the state B, when the input is 1, it goes to the same state with the output 0. So, when the input is 0, it goes to the next state C with the output 0. Likewise, you can understand the state diagram. So, from the understanding of the state diagram, this table can be filled. State assignment table can be filled. That is, what is the previous states from this state where it is going. When the inputs are 1 and when the inputs are 0, from the present state where it is going to the next state can be written down in the state table. Here there can be an assignment made, that is, we have A, B, C. A can be given as 0, 0. So this has possibility when x equal to 0 and x is equal to 1. Likewise, state B can be assigned the value of 0, 1. 0, 1. When the input is 0 and the input is 1. So likewise, C can be assigned the state value of 1, 0. So when the input is 0 and when the input is 1, where does this state go? So finding out the answers from the state diagram, we'll be able to fill this value for up to this. So this is the present state 0, 0. At that time when 0 is the input, it goes to the next state 0, 0 only. So as we already saw. So whereas here we see the combination 1, 1 is not defined in the state diagram. That's why we are not finding out the next state at this point, and we are going to take it as xxx the whole way. Through this whole way, we are taking these two values to be xxx because this state is not defined in the state diagram. Why we have to take it means because the variables ABC, which is having the 0, 0, 0, 1, 1, 0 combination, the possible combination for these two bits is the last one is 1, 1, which is not defined in the state diagram. Hence, we are taking it to be XX throughout the table for all the datas. So, here we have to find out the dx value. How we are going to find out? When the present state is 0, 0, that is dx. X means we are taking only the x value. Let's see for this example. that is x is 0 in the present state and x is 0 in the next state, then the d value is 0. Here x is 0 in the present state, x is 0, the same combination, hence it will be 0. Here x is 1 in the present state, x is 0 in the next state. 1, 0. For that we will have, that is x is 1 in the present state, x is 0 in the next state. We will have d value to be 0. So we will see the next combination here. So x is present state is 1 and the next state is 1. See the table, excitation table of D flip-flop shows that for the present state 1 and the next state 1, the output, that is the D is 1. Here for this 1 combination, we get D is equal to dx equal to 1. Likewise, the table data for dy has to be filled by taking into account the present state of y value and the next state y dash value for finding out the dy. Here n is y, that is for y and y dash value dy can be found out and the table can be filled. The corresponding outputs during the state transition is given in the state diagram, that is to be found from there and filled here. And then we are going for K-map to find out the equation for dx, dy and the output z. Dx and dy are the inputs of the flip-flops. So how to do the mapping is, where and all dx is equal to 1, which combinations. So finding out from the table and filling there 1 and grouping it this way, we are able to get the dx value. Likewise, dy equation is found out. Same like from the output values, where we have the 1 value is found out and it is substituted here in the K-map. And we are also taking into account the x. X is a don't care. Usually we consider the don't care terms in order to get the reduced variable in the output equation. So likewise we have found the output equation Z. Finally, we are going to implement the circuit. So here we are having two flip-flops dx and dy whose input equation is found from the K-map, and here from the K-map value we are drawing the circuit. From that equation we are drawing the circuit. Here the clock pulse is given simultaneously to the two flip-flop, indicating it is a synchronous circuit. So the circuit for output is also drawn, where the output Z is equal to Y into the input value.